Tuesday. My name is Nancy Crow, and I'm the Vice President of Marketing for SPAC Consulting, and I'm going to be your host for today's session. All right, to get a few things started, I'm going to mention a few housekeeping rules. If you would, please mute your mic so we don't hear anything in the background, and also join in the conversation. There should be a chat box off to the right on your screen. Feel free to enter in any of your questions. I'll be monitoring those throughout the presentation and asking our presenters to give their thoughts on a few of them. Please note I may hold a few of the questions to the end, and Bryant and Max will answer those at that point. All right, Traffic Corner Tuesday webinar series is brought to you by SPAC Consulting, which is part of the SPAC Enterprise family of companies. The SPAC Enterprise companies consist of a group of 6 traffic engineering related companies that provide a range of services, including traffic study consulting, traffic data collection products, and free trip generation data. You can learn more about any of our businesses by visiting our website or our blog on Mike on Traffic. Looking ahead, we have 2 very interesting Traffic Corner Tuesdays scheduled for the next months. March, we'll be talking about alternative intersections, and you'll have information on how to get involved in that. And also in April, we'll be speaking on unwarranted stop sign research, and look forward for more information on that. Finally, as a thank you, I want to let you know that we are offering a special bonus for today's attendees. So please stick around to the end of the session and we'll tell you how you can get a copy of our free Right Turn on Red study. And that will be shared at the end of the presentation. Finally, I'd like to introduce today's presenters. Joining me today is Bryant Fisick. He's Vice President of SPAC Consulting and is widely known in the transportation industry, having managed more than 1,000 traffic engineering projects. He is a graduate of the University of Minnesota and an expert in Syncro, SimTraffic, Bistro, and vSim traffic modeling software packages. Bryant thrives on developing creative solutions to traffic and transportation issues, and he enjoys writing case studies about unique projects on the Mike on Traffic blog. Also joining me today is Max Moreland. He is a longtime traffic engineer with SPAC Consulting. He's also a graduate of the University of Minnesota and specializes in traffic impact studies. Max is also the head of operations for our traffic data collection company, Traffic Data Inc. Max is also actively involved in managing the data for our free trip generation website, tripgeneration.org. And as many of you know, Max is also the co-author of the Traffic Counting Manual and a regular contributor to the Mike on Traffic blog. Please join me in welcoming Bryant and Max.
All right. Thank you, Nancy.
Thank you.
All right. Back again. So we'll start off, obviously, we're talking about Right Turn on Red research, and to give a little shout out to Tony Trammell, Right Turn on Red after stop. So that's something we don't often think about, the after stop, but we want to make sure people do stop before they take that right turn on red. So just a quick shout out there, Tony. But to take a step back, just before we get into the specifics of this research, you can see up on the slide there, the question is why? Why are we doing this research? Why are we looking at this at all? And so as part of our company, our purpose is to improve transportation globally. And this is something I don't think we advertise enough, but that's what we want to do. So obviously we want to make money along the way. We are a company after all, but we want to improve transportation and improve what we're doing.
And within our purpose, we have 4 core values that go by the catchy acronym of ERIG: effective, respectful, innovative, and giving. And research projects like this kind of hit each of one of those core values for us. They are effective in that we are getting better data, that we can be more effective in the studies we do. We're respecting our clients and our employees by giving them the chance to research valuable information and do our studies, the right way. So when our clients come to us, we are doing projects with the most up-to-date information that we have and doing things well. Innovative, that one's pretty clear. It helps us be more innovative.
I think so.
And giving, we give this information out freely in a lot of cases, or at a small cost. But we give this information out there, like what we're doing right now. We're sharing this information with others so other people can use it.
So that's a little bit of the backdrop. You can see this in some other areas. Just briefly here, these are some of the other things we have available. At SPAC Academy or Mike on Traffic, some of them free, some of them for a small cost. But this falls right into line with that. We do some research, we develop different things. The warrant analysis spreadsheet, that's a big one internally for us.
Yep, I use that all the time.
But they're things that help us get better, help us meet our purpose and our core values, and we make available to people. And then also just briefly, some other topics that we are working on. We're looking at 25 versus 35 mile an hour posted speed limits on residential roads. Nice long title there, but Minnesota is a 30 mile an hour state. Wisconsin is a 25 mile an hour state for residential roads. It's kind of the statutory, posted or not. And we're going to be looking at that to see if there's any difference in the 85th percentile, the 10 mile an hour range. Just, is there a difference in the speeds on those roads just purely based on that backdrop of what's posted there?
Another project we're working on right now is a stop sign compliance project. We're working with a number of different cities, mostly in Minnesota, some elsewhere. And we're going out getting counts at intersections with stop control and figuring out just what is stop sign compliance at different types of intersections with different characteristics, different speeds, all that different stuff. And really just hopefully we can find out if there's clear guidance on when stop signs are followed and when they're not in real life. Yeah.
All right, so that's the big backdrop on why we're doing research in general and what we're looking at. A couple things there. And so now kind of getting into the process for research and what we look at. So for the very first thing is, what's the issue? What's the goal? What are we looking at? And so we look at this a couple different ways, internally and externally. Internally, are there issues with how we work? Can we be more efficient in what we're doing, more effective in what we do? Are there different ways to look at analyzation, that sort of thing? What type of research will just help us get better? And then externally, with mainly with our public clients, but what kind of questions are we getting? What kind of questions are we getting from them? What are they getting from their councils or boards? Just things that come through our clients. So there's tons of research projects out there, obviously, lots of different things that could be, but we're really focused on what is going to make us better or what's going to make our clients better. So that's how we start to look at what the issue we want to research is.
And then another big part of our process is defining success. We can go out, we can collect all the data we want, but we kind of need to know what we're looking for. Not that we're picking how the project is going to end, but we need to know ahead of time at the beginning of the project whether our assumption has been met or been not met.
If you think back to old school science fair, it's kind of the same thing. What's your hypothesis? How do you determine if the research has met your goal or met your expectations or not? So you need to define that up front. Once we have number 1 and 2 defined, determined, then we can figure out, well, what's our process? How are we going to get from one to the other and make sure we're meeting that end and reaching what we set as our expectation or getting to success. And
then we actually have to do the work.
Obviously, that's step number 4. Make sure we do it.
Yeah, make sure you do number 3 before number 4, because yeah.
Yeah, great point. All right, so then moving into right turn on red. So Minnesota state statute, this is an abbreviated version, but basically in Minnesota, the driver can come up, make the stop at the red light, and then make that right turn after stopping. So that's, like I said, abbreviated, but directly from our state statute. So as we looked at it, again, kind of stepping through our process, what is the problem or what's the issue that we're looking at? We're starting with essentially this is a screenshot of Bistro. This is one of our, or I guess the primary analysis software we use. So when we're doing our traffic impact studies, this is what we're plugging in. We're drawing the networks, you can see on the left side, and putting in that information. So if we look at this signalized intersection, what's highlighted down there is right turn on red volume. This is an open cell. So this software does not calculate the right turn on red volume. So we have to manually input that.
Yep. So that's a part of our process. You can leave it at 0 and move ahead, but that's not really realistic. So a few months ago, maybe last year, we kind of had an internal talk about this. How do we approach this line in a Bistro network? And everyone had a different method, to be honest, in the office. Every engineer who works in Bistro, works on our impact studies, had a different method for picking what number to put in this right turn on red volume. Some just picked a straight percentage. Some
That'd be me. Yeah, I picked a straight percentage.
I picked a straight percentage depending on the kind of the configuration of the intersection. I had a couple of percentages I would pick from. Others would do some crazy calculations based on the signal timing and their middle name and other things. So we realized no one's doing it the same way. So we should really figure out what we should be putting in here.
Yep. And so that became, that is the issue then for us. And that's how we define this research, is just trying to figure out what process should we use, and whatever that process is, we should probably have some backing to it as to why we chose that.
Yep. The other software we use for traffic studies is Syncro. And Syncro is different than Bistro in this case, because Syncro automatically puts in a right turn on red value for you. You check whether you want it to or not, and then it calculates using math, I assume, some number to put in for the right turn on red value. Whereas in Bistro, you have to manually enter the number you want.
So in this screenshot down in the lower left, you can see highlighted in red, like Max just said, if this particular intersection, it allowed right turn on red, you check the box, and the blue number below is automatically calculated. They don't publish that formula. They just say it's complex and it's based on many factors, including the signal timing, the volume, but they don't really get into it. So it's, even when we're using this one, we're taking it on faith that they're calculating it correctly. So for the two softwares we use, it's kind of a check on that, get a process, or make sure that the process they're using is correct. And there's other software out there, and they're going to do one of those two methods also. So this could also be used for those software. This isn't specific to those. This is specific to a process for looking at the right turn on red percentage.
So that brings us to the goal of the software. Is ultimately we use Bistro very commonly. So this is for us to develop a procedure for Bistro for right turn on reds. And secondarily, we also use Syncro in some projects. So it's kind of give us that check on whether the automatic number they select is appropriate.
I have a question from Tony on the example that you just had on the page before. And he had asked, in this example, why would you even consider a right turn volume?
Yeah, I guess he's referring to the free right and why that matters there. It's still a merge. It's still a calculation that Syncro takes into account. To be honest, there wasn't much thought into what this represented. It was mainly just a screenshot just to show that Syncro has this ability. Don't read too much into this specific example.
Yeah, I don't know what it's from.
All right, so we got our issue. We've got our goal. So the next thing is just the procedure and the work to get this done. And we're going to kind of combine those steps as we talk about it here. But one of the first things we wanted to do, and one of the first things we did for our procedure, is just find out what's the impact. So we wanted to make sure we weren't making a mountain out of a molehill. I mean, if that right turn on red percentage made no difference, then we don't need to do the research. It doesn't matter anyway. So we wanted to step through and just what's the impact of that.
Yep. So what we did is we built an intersection in Bistro,
Yep.
and we a signalized intersection, put the volumes in there, and then we just adjusted the right turn on red percentage on one of the approaches in 25% increments. So 0, 25, 50%, 75%, or 100% of the vehicles turning right on red. And you can see on the right side of this chart, the far right column, the overall intersection delay didn't change too much. It dropped a little bit when you kind of have all the rights turning on red, but the movement and approach delays dropped pretty significantly. Could drop a whole letter grade if in a level of service scale. So this shows us that the right turn on red inputs do have an impact on the intersection analysis and the delays you're getting out of that, which could lead to an impact in recommendations from a study, which could lead to real life impacts of different treatments being constructed out in the field.
Yeah, if you look at that movement and even approach, if you do that, that was just one approach we changed.
Yep,
if you did that for all four, now you could have a real impact on stuff. And this doesn't get into queuing either, but as we kind of looked at that too, that all makes a difference. That all gets back to the intersection, and again gets back to how we think things are going to operate, and then our recommendations. So basically, out of this, it was, yeah, it has an impact, and this is an important thing that we should move forward with. So then our next step, we looked at to be more efficient. We were doing some studies in these areas. So these are 4 different cities. We were looking at 11 intersections. We were already getting counts there, so we added on this research to it. So we went out, we got turning movement counts at 11 intersections in these 4 cities, 29 different approaches that had the criteria we were looking at, and we were able to record, I said, all the movements there, but then also look at the right turn on red and specify that volume as opposed to all the right turn traffic.
Yeah, and using our videos from our count cams, we were able to go back and count those right turns separately. We did a full count of the intersection, then went back and just counted the turns actually happening on the green phase, because that was, it was easier to count and felt more accurate, and then subtract those from the total right turns to give us our number of right turn on red at each location. And the locations have different characteristics, different speeds on the conflicting roads, different opposing through lanes, volumes, different signal lengths. The percentage of red time was different. So it gave us a nice variety of sites to look at. Yep,
and what Max just mentioned there, those were the key characteristics that we wanted to record for this, for the right turn on red. As we thought about the research, the process, and what we'd be looking at, we were trying to think of what might correlate to that percentage of right turn on red. And that's what we came up with. Does the speed matter? Does the number of opposing lanes? How about the volumes? How about the signal timing itself? So those were the key ones that we looked at and said, let's graph those. Let's see what we can find and if there's any difference there. For the actual research, we focused on the AM and PM peak hours. Yep. So we did have more counts than that, but really our studies usually focus on the peak hours. So,
did you make the screen as it advanced?
Nope, no. I'm still on the map. Yeah, so that corresponds to most studies, so it made sense to focus on those peak hours.
And one other thing, we just to kind of simplify the world of options we could look at. We looked at only approaches with exclusive right turn lanes, not shared through right turn lanes. So, yep.
Okay. All right, so moving on. Now that we gathered all that data and brought it back in, now we begin the process of going through and trying to graph everything according to those characteristics. So the very first one we've got here is percentage of right turns on red after stopping versus the cross street volume. So you can see we've got two different graphs there for two opposing lanes if they're turning into two lanes or if they're turning into just a single lane. Volumes all over the place. So we got 29 different dots there. Yeah, I didn't make anything out of this one.
Nope.
So it's all over the board. It's up and down, literally up and down as you move across. So no correlation that we could see for the volume.
Next way we try to look at it is splitting up by the speed limit on the cross street. So if vehicles are turning right onto a 30-mile-an-hour road, is that different than a 55? You can see the different colors here. It looks like an abstract painting of sorts. Again, no strong correlation here. So this is the same graph as the previous one, just we grouped everything into speeds, and it doesn't seem to be a strong indicator of how many right turn on reds you're going to get.
It does make a pretty abstract picture, though.
It's nice.
So
Yeah.
we do have that going for us. But yeah, otherwise, so we're 0 for 2 at this point. No correlation, no real process to speak of. Next one we looked at, this is looking at the signal time length itself. So as we looked at the right turns in general, the right turns on red, how much red time are they facing for that signal? So if you think about it, if it's a typical 100-second cycle length and it's split 50-50 between the two approaches, that would be 50% red time.
Yep.
So that was a key one we looked at. So this one you can see, again, graphing it with the single approach lane there, overlapping it. The blue line here is the duals. And so as we looked at this, we started seeing a little bit of a trend line there. So generally, as your percentage of red time goes up, you got a higher percentage of right turn on red.
Yep. There's a few outliers. Those some of those are actually due to the coordination along corridors. So if there's just less right turn on reds because there's less vehicles approaching a red, that could lead to an outlier. But in general, it looks pretty good.
And if you think about this intuitively too, I mean, that makes sense. If you have more red time, you have more opportunity to take that right turn on red. So kind of a duh moment, I guess, as we look at it and say, yeah, that makes sense. It's probably where we should have started.
Yeah.
So coming out of that with that graph, basically now we're okay, we've gone through it. We made that. What's our takeaways? Trying to get back to our goal. What was our goal for it? What was our procedure? So as we looked at it, the percentage of right turn on red is at least 30%. So the average was 50, but I know before this, when I started, I just randomly picked 20 or 25%.
Yeah.
I had no basis for it. That seemed reasonable to me based on what I knew. So I need to bump up what I'm doing. So at a minimum, it should be 30% based on the research we've done. Next thing you can do is consider restricting factors.
Yeah. So if there's high pet activity, high volumes, no gaps, really, sight distance constraints, if you can't see to be able to safely make a right turn on red, those are things you're going to have to consider. So obviously every intersection should be considered individually, and we don't recommend just putting 50% across the board, but that is kind of a place to start.
And this is all stuff you should have with you. None of this should be extra stuff you're getting. But if you start with between 30 and 50, you can just take a quick look at, you've either been out at the site or someone you're working with has been out at the site, and you can look at the counts. Just what do you think is going on there? You can look at the video, just a very quick check and just, okay, yep, 30% seems reasonable. It's backed up by other things. We're good to go. At the other end of that, if you want to go above 50, then you should probably have a pretty good reason. And one of the good reasons for that is the signal timing itself. So if your signal timing is skewed 90% on the main line, 10% on the side street, something big like that, well, yeah, just like we showed in the graphs, they've got more opportunity to take that right turn on red. You can bump that percentage up. Just make sure you document that somewhere so people know what you did. again, engineering judgment and everything, but have that good reason and move forward with it. Don't be scared of going to a higher number.
Yep. So those first three results are applied to kind of Bistro, putting in your own number. We also found result number 4 here that you can trust Syncro. We did a double check, or also you should do a double check on other automated software if you're using that for intersection analysis. But the results that we found from Syncro were pretty in line with the results we saw from our research.
Yeah. So kudos to them.
Yep,
They did a good
doing
job.
it right.
Yes. All right. So with those takeaways, again, we have reached the end here. We got a few minutes left, but thank you for joining with us on what is admittedly a little bit of a dry subject, very technical, but tried to add some in there with the process and everything. If you have any questions, we're happy to answer those. We'll stay on the line as long as necessary. So thank you very much for attending. Also, we do have the full study available. The text is on there, or email Nancy. Either of those will get you the little research paper we put together, and you can read a little bit more about what we've got. We've got the actual locations we looked at, more of the processes in there, so that explains more on everything. Last thing I'll mention, as people are either leaving or heading off, but for public agencies, if you are interested in our 25 versus 30 mile an hour or stop sign, or have ideas of other research, we're always willing to talk and listen. You can email me. I'm happy to start that conversation, either about our ongoing research or potentially new ones. Always looking for those new ideas.
Okay, we do have a couple questions. One question is, just a moment here, I kind of lost my place here. Is the route choice considered in the right turn on red analysis, or is it just a microscopic analysis?
So we did not consider route choice in this. We just looked at the intersection itself.
Yeah, I mean, this was purely just as we look at an intersection, what's that percentage of right turn? And we phrase it as percentage because obviously those numbers are going to go up and down. And it was purely just as we look at our procedure from study to study, we want to be consistent and we want to have some backup for what we're doing.
Okay. Also, Tony was wondering, in our observations, how many actually stopped, a cessation of movement that was observed?
You might be in a better spot to answer this than me.
So with these counts, we didn't do a stopping compliance. We just counted if they made that movement through
On the green.
on the green, and subtracted that from the total to give us how many turned right on red. We didn't actually count if they came to a full stop or if they rolled through or anything like that. That wasn't really what we were focusing on, the counts.
You have a guess?
No.
I know at a signal, there's usually a little bit higher volume. There's a reason the signal goes in there. So my guess would be it's probably higher, but there's still a good percentage of people that roll through, even if they're facing a red light.
Guys, did you also consider the VC ratio of the mainline traffic?
To a degree, that's what we tried to do with the volume. So not specifically the volume to capacity ratio, but the volume itself. So, and that was one of the first charts. I can flip back to that one real quick. Bear with me. Too far. So on this one, we tried to look at that cross street volume, not necessarily just how much it was to the capacity, but just with an expectation when we went into it that more volume would mean less gaps, less right turns on red, that they needed the green. And that wasn't the case.
Yeah, and we split that up into 1 lane, 2 lane, so you can kind of get a sense of capacity within this chart. If there was like a Z-axis and we went 3D with it, right? But it's PowerPoint, so we didn't.
I'll take your word for it.
Say, Max, David was wondering, was the geometry a consideration, such as the acceleration lanes, curb ratio, any of the channelization?
Yes, I'll take that one, Max.
Sure.
Yes, as we thought about this research project, again, there's a number of different ways you can take this. So we tried to limit what we were looking at and make it more applicable to what we were doing. So we focused on exclusive right turn lanes that came to a stop. So no channelization, no acceleration lane, just an exclusive right turn lane comes up to the stop line and they go around. We did not look at the radius of that curb though, which obviously would impact the speed they could go around.
Yeah.
So that could be a factor, but we tried to look at the same types of characteristics for the turn lane itself.
So Brian, if you want to move us back to the very end of our presentation, I just want to remind our attendees that, again, SPAC Consulting, one of the things that is part of our values is to share our knowledge with others. So we have been doing these different studies. We do have a stop sign compliance study that we're in the process of putting together, as well as the speed limit, the 25 versus 30 mile an hour speed limit that Brian had mentioned earlier.